Hello, and thank you for joining me. You're here with data science teacher Brandon, and we're going to do a deep learning computer vision project for a pneumonia detection problem. So, binary classification, do they have pneumonia or not? Okay, awesome. So, let's get started. And what you'll need to do for this data set, I'm not able to put the stuff in my GitHub repository. I tried, and maybe there's a way, but I haven't been able to figure it out. And so these images you need to download these. Okay, and so you'll connect it to basically the folder that you'll download. But here's the link to go connect it, and it should be down below the video on the website. Okay, so check that out. Okay, so if after you've done that, you want to import your drive, so from google.colab, import drive.mount. This connects this Colab document to the folder because they're on the cloud. So although they look next to each other, they're kind of floating around on the cloud. So this is basically saying, here it is, and giving it permission as well to enter your drive. Okay. Although technically it does live next to it, it's on the cloud, right? So it'll be a little bit more. I gotta protect the security. Okay. So here what we're gonna do, we're gonna import some libraries, standard data science libraries, just in case we needed them. And here we're gonna do TensorFlow as TF. We're gonna import yeah, and so we'll give it permission to connect to my Google Drive. Okay. And so we're gonna go TensorFlow as TF. We're gonna go OS and just as an OS, and it's already short enough, and CV to inspect some of the images. We don't really need it for the model building, but to allow us to inspect some images, we use these two today. So we'll next do, it's always a good idea, you can see here I'm printing out 2.11.0. So what you'll do here is if you go to TF, because they're updating this TensorFlow library just so much. It's kind of annoying, truthfully. There's updating it just so much. It's good to print out the version of really even your own projects, just so that when you come back to your own projects, you can see which version of TensorFlow you used. And if they've updated, likely they have, and likely some things are a little bit different. And it's just a very likelihood. So it's good to put a little bit of extra effort into this and be aware that you're dealing with a library that's evolving very quickly at the moment. And so we have to just make sure that we know what version we're using just in case, because well, things are going to change. So okay. So what we'll do here in the next one, we're going to assign the file path here. What we're going to do is we're going to do cv2.imread. Oops. Dot where the none is. So and then im. We're going to give this file path. This is my file path. Now that I've mounted my drive, I can go all the way down to the files, and it'll be in your G drive, in my drive. You just find out where the actual photo is. Just pick one of them, and you'll go copy file path. So just notice that I'm taking the first ones there from the normal data set right there. Okay, so I'm doing normal. I'm going to put that in the image just to make it a little bit clearer here. I'm going to call this image. So I'm going to read this into image. And then what I'm going to do is I'm going to do plot im show. Okay. And we'll be able to inspect. So just take a look and really see what we're trying to predict. Okay, it is definitely helpful. This is a little bit different than EDA in with the spreadsheet and regular machine learning, but it's still such an important step to understand what we're doing. Okay. Oh, and you got to make sure you spell things correctly, which if you watched a few of my videos, I always get everything correct all the time. And that's the kind of, there's nothing wrong with getting an error. It's just kind of good to go fast a little bit and just listen to the errors and keep on trucking. Okay. So here we got our image. I printed out just like what the actual image looks like. So it's just an array of these values. And we can see what it plots here is kind of just a chest x-ray image, nothing super interesting. And that's what we're predicting today. And then looking at another image, we're going to go do this again. We're going to go cv2.imread, read in the path again, inspect another one. I'm also printing out the shape. We're not going to use this. They're actually quite large images in terms of the number of pixels. So that's very large, and which is common in medical data sets. They're quite, there's a lot of data in them to make sure they find what they're looking for. And however, we're going to do something a little bit smaller. Just if you want to use memory, you'll be able to make your image sizes much, much bigger. But no, um, we're going to do something a little bit smaller today. So again, we're assigning our file path, and we're putting path here, and we're using the three little dots right here, oops, on the side of our folders right here, and copy path to get our file path. And so we're doing that, and then we're doing another image right here. We're loading up another one, making another checksuccess array. And then again, in the last thing, after we load up our file path or looked up our image, we're also going to go image.shape, and this is just a NumPy array at this point, and it will give us the shape of the image. And you can see quite large, 1000 by 1100, not even either, which makes it a little bit difficult, but we'll be able to use in the image data generator that we'll use today, we'll be able to set the image size, which is what we'll do right here. Okay. So we're going to create a variable called image underscore size, img underscore size equals to a pretty small size is more than good enough for most computer vision problems. In a medical situation, you probably use something bigger. A next common step up would be 256, 256, maybe 512, 512, and so on along this pattern. It's usually good to stick with this. Okay. So here what we're going to do is we're going to set up the file path for our image data generator. So here we got is os.path.join. Going to give it the file path. And just notice what I'm doing here is I'm giving it right to the folder, the main folder that would hold train and test. Okay, so the folder above that holds train and test, I'm giving access to that folder. That's my main data directory. Let's call it. So the next one I'm going to do os.path.join. I'm going to go data directory, data dir, data directory, and then I'm going to add train to this. So it does a little bit more than this, but it's just actually putting a line in here and then joining the train. Okay. So then what we're going to do is we're going to print out how many values we have in each one. So train normal os.list list directory, and this will give us the values in that, so the number of files in there, the list each directory in each file in that folder. Here we're going to go file path or os.path.join, okay, giving it the train directory up above, and we're going to do normal, and so we're going to get the normal folder, the normal images right here. In the second one, we're going to go list directory os path.join, and then we're going to go data train directory, and we're going to do the pneumonia, just so we'll be able to see now. This is going to allow us to see how many images we have in each one. We have quite a few pneumonia ones and not as many normal, which is interesting because normally you have less medical ones, but okay. So here we're going to do the next one, and the next one in the test directory, we do the os file path join. We're going to do the data directory, the main file path that holds the two folders, the train and test folder. Okay. Then what we're going to do is in the next one, os list directory lister to get the list of every file in there, the file path list of every file path in that folder. And then if we join to the number, or sorry, we're joining the normal to this, so we get a list of all of the files in the normal one. And if we get the length of that, we'll get the count of that. And then the next one, os path.join. Okay, so there we go. And we got our file path, we got our images set up here, and we can see there are quite a few in our train. And it really, this is the trick, I guess, to computer vision. Not the trick, but one of the tricks is really how you signify your classes, signify your train and test set. That split is done with how you organize the files in the folder. And most of the time from Kaggle, they come pretty nicely organized, so it's not so bad. Okay. So we're going to set up our image data generator. Okay. And so this is a little bit different to work with than if you use pandas, but it's not so bad once you get used to this. So we're just really setting up a connection. Well, an image data generator is going to have a connection right to the folder. It's going to pull in images and augment them on the fly. So we're going to basically be able to simulate thousands, hundreds of thousands of more images, and we'll be able to hopefully get a really good model with this many images. Okay? So what we're going to do next is we're going to set up the data generator object and train and test. So what we're going to do in the train, we're going to augment the images on the train just so that we can do so we can get better on the test set, right? We want to make sure we're good on the test set. So we're going to do pre-processing So TensorFlow tf.keras.preprocessing.image capital I image capital D data capital G generator. And then we're going to rescale our images, which is classic kind of computer vision, super easy to do the standardization of your images, which is funny that it's easier than in on a regular spreadsheet, but something's a little bit harder, I'd say. But that's definitely easier. Okay. So and then we're gonna rotate our images up to 10%. We're gonna 10 degrees. We're gonna do a width shift up to 20%, height shift up to 10%, zoom range up to 1. I would be careful playing with the zoom range too much. If you go too high, you're really gonna notice. If you play with any of these too much, you're gonna notice your model just starts not really training very well and stuff like that. So you could try increasing these, but do one at a time. So really notice what's going to affect you. I almost guarantee you, because I do this a lot, because it's like, oh, let's turn all these up. And then the model doesn't train well. So then I have to go back and then do one by one. So it's just giving you some advice. Start with one by one, and you'll end up saving a lot of time. Okay. So doing that, on our test, we're just going to rescale them. We're not going to really do any augmentation aside from just scaling the data set, which I guess is a form of augmentation, but not really in sense. Okay. So then the next step, so this builds our generator object. We're going to then do our flow from directory right here. So we're going to do flow underscore from underscore directory. And this is TensorFlow, so we like to write things out very long and stuff, but it makes it a little bit clear what we're dealing with. So this is our data generator. That's the augmenter. That's then connecting the flow from the directory to do the training stuff. So we're giving it the data directory that we set up above. We're going to do our target size is equal to, the reason we inspected the images was to get an understanding of the image size. We set our image size. Here we're going to be using that image size. We're going to do a batch size of 8. You can do much larger than this if you want to. We're going to do color mode, RGB, is just 3 colors, and then class mode is capital. So we're doing that, and we do one for, we basically do these the same for the train and test, because it's just, again, the thing that's pulling in the data. You could do different batch sizes, I guess, if you wanted to, but really the image size would be the same, and the directory. The only big difference here is a test directory, and this is the train directory. So, again, it's all really computer vision about really organizing your files properly. So here, a generator object, this generator object is not like a pandas data frame where you just show it. We have to kind of iterate through, we have to kind of start using this to be able to get things. So just to show you in a very simple, very simple sense of how we would use this, we're going to set our batch size to our generator object. So we're going to kind of initialize this, and we're going to say batch I, and then 0 is going to be the image, and 1, so it's going to be basically pulling out a row at a time and iterating through this. It's going to take a little while to run. So let's start talking. I'll talk while this running, and then we're going to go I. We're going to print the class. We're going to go IAmShow. So it's going to IAmShow image 0. So it's going to take the image out, and it basically is going to be the image now. And then it's going to be the argument here is going to be argmax. So argmax, because we're going to be predicting we're going to use a categorical type of prediction here. So it's going to be each one of the columns is going to be a different class. The highest column with the highest prediction is going to be our final prediction. And that is going to be argmax is going to give us the index position of where that is. So this is saying index position 1 is pulling that up to the right. So it's the second position. So that would be true. So here you can see our augmentation, we're shifting it a little bit. And you don't want to shift it too much. It's good to shift it a little bit, but honestly, you might not really want to see this too much. But it is. This one doesn't really have too much augmentation to it, so it really will depend on each image, right? So again, we'll just be able to do this every time. Okay, so let's get into our architecture, our model building. Okay, so for convolutions, I really find you might find, and it really will depend on the data set, but I really find 10H is a good one. So we're going to go tf.nn 10H, just an attribute here, so no parentheses. TF, just to make sure we use TensorFlow for more than one reason aside from the model. So we've got to use it as much as possible. tf.nn.alu, and then tf.nn.softmax. We're going to do a softmax output because we're going to set this up as a classification. So this would expand very easily two multi-class problems that we're going to do. I'm not going to go through that. So we set up our convolutions here. We have kernel size, so the 3x3 grid. The pool size is how much we're going to be pooling on our max size, our activations, our neurons, and dropout layer is going to be 0.4 or 40% dropout, which you actually really want quite a good dropout. It tends to really 0.4, even 0.45, sometimes even 50% is getting a little bit too much, but here we're going to do 40 epochs, and we're going to do in our optimizer and our loss. So setting up our optimizer and loss, I really find it's just good to have all of our hyperparameters and easy to find and easy to see thing above, because it gets pretty big. This is a very simple architecture, but it can get pretty big. So this is just a good way to stay organized and make sure you know what's going on. Okay, so tf.keras.optimizers, and here we're going to use the atom optimizer. Okay. Next, we're going to use loss. So we're going to go tf.keras.losses. Okay. And we're going to go categorical. Oops. Categorical cross and capital cross entropy. Okay. So categorical cross entropy. And that's going to be our loss function for this one. Okay, so let's get setting up the actual layers in our model. So it's the hyperparameters. And here we're going to set up, so tf.keras.models.sequential, capital S, sequential. Then we're going to start defining our layers. So first we're going to do a convolution layer. So tf.keras.layers. Layers, and then cov, capital C, cov, COV, 2D. Oops, 2D. And we're going to do cov neurons. The kernel size activation is going to be right here. We're going to put input shape. We're going to do it right here, 28, 28, 3. This is different than the image sizes. Now we have the 3 channels. It's the big difference between the image sizes. These image sizes are the same, but we're adding a third position, the 3 colors, the color channels. So then we're going to do tf.keras.layers.max, capital M max, capital P pooling 2D. Pooling 2D. We're going to then do right here, we're going to do capital D drop out. Okay, we're going to drop it at 40%. We're then going to flatten our images. So get rid from the square format down to just flat, so we can work with the dense layers. Okay, then we're going to do dense, and then this is our dense neurons, our dense activation that we set up above. Do another dropout layer. Really good to just do dropout layers up between, kind of, especially dense layers to get really. And it kind of feels like they just get clunky, like kind of stuck going through one path very, very easily. So if you see dense layers, it's really good to do these dropouts. But really, dropouts are super important in lots of places in your network. Okay, so in our output layer, we're going to do dense, and we're predicting 2 neurons with our activation on the dense act right here, our output act. And I don't have that set up here, output act right here. Okay, so output activation in your select acts. Okay, so we're going through those ones right here. Building our model right there, we have our 2 outputs right here. We're going to compile our model right here. So loss equals the loss up above, optimizer equals the optimizer above. Metrics are accuracy, because just seeing the categorical cross entropy, that it's not super understandable. It's just a number, really, truthfully. And so we're just making sure we look at our metrics right here. So then just going model.summary to get a look at our neurons. Okay. So then we'll fit the model. So fit. And here we're going to go generator underscore tr for the training generator. And then we're going to go validation data underscore data equals generator test. Our epochs are going to be the EPS that we set up above, and our batch size is going to be T. Okay. So I'm not going to run this right now. I'm just going to, I'll start with this, explain this. Let's go through. We ended up getting a pretty decent score. Not great. It's a very simple model though, so there's many ways to improve this, and we'll learn as we go through the next guided projects. Okay, so just to go through this, pretty easy. And here's the last step. Let's just make sure this starts training and it works good. Hopefully, do a good model. It's going to take a while to train, though. I'm going to say quite a while to train. I'm using a GPU right now, even, but it's still going to take a while. So starting, well, that's starting to train. Just make sure everything works good, and we're going to set up the plot history. So just notice right here when I'm training, I'm going h equals model.fit. Okay, so we're going to need to go data frame, and here we're going to go h dot history, and then that's going to be our data. It's going to be a data frame object then, and we're going to plot that. So this really just fits very well. It's just a dictionary of lists, and then it just fits really nicely into basically the keys become column titles, and the list becomes the column. And then we can plot this in pandas data frame, and we get this nice easy color. We can see we drop really easily to the train. Because this jumps around a lot, this is actually because of the data augmentation. It does. This is kind of a good thing because it's really just making sure that we're not getting stuck to one image being in a certain place or one certain direction, certain rotation, where we're augmenting the images to hopefully build a more robust model. Okay, so really you could actually change this for quite a lot longer. I just did it for a little bit to show. So just to see, I mean, this does take a little while per epoch, so I'm not going to sit here and wait for this to train. But now that we know that it's working, you can then plot the history after and get it done. We'll look at how you would evaluate the model. So you just go model.evaluate and model.evaluate for the test set. And so you're just giving it the generator train, generator test. We do have some overfitting going on, and there's lots of stuff that we wouldn't have to deal with that. But this is again a very, very simple model, kind of the simplest you can be while still using the data augmenter. So it's really simple. We can still get a really good model. I think that's a great lesson to start simple, and then we'll plan, or even when you're building your own models, start simple and then build the complexity up piece by piece. You know what each piece, what effect each piece is having. So starting complex and then not knowing what each piece is really doing. Okay? So thank you very much for joining me today, and I will see you on the next project.